Inside some computer chips is something known as pipelining. It uses a technique known as speculative execution to speed up processing. What it does is simultaneously execute a number of instructions ahead of the current location. As you can imagine, there are a number of problems in doing this: numbers not being ready, things being moved into registers too soon, and so on. But the biggest problem is conditional branching. The speculative process tries to predict whether or not a branch should be taken, and if it guesses wrong, the effort spent executing instructions will have been entirely wasted. Now, to avoid this problem, you can try to write code that avoids conditional branching. But as you know, in assembly language, decisions are made by setting the condition codes, the flags, and then using a conditional branch instruction to jump to another location. But there are some ways to make decisions without branching, but it's never straightforward. Here's an example. This function prompts for two integer values, then it displays the larger of the two, and it does it all without a single branch. It begins by prompting for an input value, then places that value in value 1. Then it prompts for another integer and leaves that value in the EAX register. Then comes the process of selecting the larger of the two numbers. First, the EBX register is cleared. A simple way to set a register to 0 is to exclusive OR it with itself. It takes up less space and is just as quick as copying 0 into the register. The compare instruction is used to compare the two values and set the flags. The BL register is set according to the flags. If the greater than flag is set, the BL register is set to 1, otherwise it's left at 0. Now the BL register is the lowest 8 bits of the EBX register, so in effect EBX is set to either 0 or 1. The NOT instruction toggles all the bits, resulting in a 1's complement of the number. Then 1 is added to that number, giving a 2's complement. That is, the least significant bit was duplicated throughout the register. If the register started out as 0, it remained 0. If it started out as 1, it became -1, which is a register filled with 1 bits. This result is moved into the ECX register. The second value, which is still in the EAX register, is ANDed with this result that was copied into ECX, so now ECX contains the second of the two values, or it contains 0. The EBX register is then toggled to become either all 1s or all 0s, the opposite of the mask that was copied and built into the ECX earlier. The other value, value 1, is ANDed with this new mask, so now one of the two registers, ECX or EBX, contains the larger value and the other contains 0. Finally, these two registers are ORed together into the ECX register, which now contains the larger of the two values. So the value we're after is in the ECX register, so now it's only a matter of displaying it. And this is how it runs. As you can see, the second number is the larger of the two, and that's what it displayed. It will also display the first number if that one happens to be the larger of the two. As you can see, it's difficult to do things without branching. It takes some creative thinking, but you can come up with some amazingly efficient code. but you have to fully understand how the bitwise operators, the shift operators, and so on work. And above all, you must understand the fundamentals of binary operations. And it would be wise to study the opcodes available to you on the machine you wish the program to run. As you explore the instructions, you will find that some will cause you to wonder why they are there, but like the set G instruction, you'll find them useful for special circumstances.